light speed. It's the universe's ultimate speed limit, a fundamental constant in physics. Nothing can travel faster than this cosmic speedster. Light zips along at approximately 299 million meters per second. According to Einstein's theory of relativity, this speed limit revolutionized our understanding of space, time, and gravity. The speed of light in a vacuum is constant for all observers. Imagine a beam of light racing across the cosmos. No matter how fast a spaceship travels, the light beam will always move away at light speed. Now, let's turn our attention to the vast expanse of the universe. We observe distant galaxies rushing away from us. The farther away they are, the faster they seem to be receding. This observation, based on the redshift of light, suggests that the universe is expanding. But here's the rub. If the universe is expanding and galaxies are moving away from each other, aren't some galaxies moving faster than the speed of light? This seems to contradict everything we know about the universal speed limit. Is the fabric of reality unraveling before our very eyes? Don't panic just yet. To resolve this apparent paradox, we need to delve deeper into the nature of space and time themselves. Our classical Newtonian view of the universe, with its static, unchanging backdrop of space, is simply not sufficient to grasp the complexities of the cosmos. We need to enter the mind-bending realm of Einstein's general relativity. Einstein's theory of general relativity provides a more accurate and complete description of gravity. It goes beyond Newton's law of universal gravitation by describing gravity not as a force, but as a consequence of the curvature of spacetime. Imagine a bowling ball placed on a trampoline. The ball causes the trampoline to sag, creating a curvature. Similarly, massive objects in space warp the fabric of spacetime around them. This curvature of spacetime affects the motion of objects, including light. Light, although massless, still follows the curvature of spacetime. This is why we observe gravitational lensing, where light from distant objects is bent around massive galaxies, creating multiple images or distorted arcs. General relativity revolutionized our understanding of gravity and its effects on the universe. It provided a framework for understanding the expansion of the universe and the behavior of objects in strong gravitational fields such as black holes. The fabric of reality, space-time, and its secrets. To understand how the expansion of the universe doesn't break the speed of light, we need to shift our perspective. Instead of thinking of galaxies as moving through space, imagine space itself expanding. It's like dots on a balloon. As you inflate the balloon, the dots move further apart, not because they are moving across the surface, but because the surface itself is expanding. This is the heart of the matter. The expansion of the universe is not the motion of galaxies through space, but rather the stretching of space itself. It's a subtle but crucial distinction. When we talk about the speed of distant galaxies, we're not talking about their speed through space, but rather the rate at which the space between us and them is stretching. This stretching of space is happening everywhere in the universe, even between you and me. However, on smaller scales, the effect is so minuscule as to be unnoticeable. It's only on vast, cosmological scales that the expansion becomes significant. The expanding universe, a new perspective. Think of it this way. Imagine two cars on a highway. They are both traveling at the speed limit, 60 miles per hour. However, the road itself is stretching, adding more distance between them. From the ground, the cars appear to be moving apart faster, but neither car is exceeding the speed limit. It's the road that's expanding, carrying them along. The cars represent galaxies, the highway represents space. The speed limit is the speed of light. Galaxies aren't moving faster than light, it's the space expanding, creating the illusion of speed. This has profound implications for our understanding. The universe is dynamic and evolving. Conclusion: the speed of light remains unbroken. The expansion of the universe, while mind-boggling, does not violate the universal speed limit set by the speed of light. The apparent faster-than-light speeds we observe for distant galaxies are not speeds in the traditional sense, but rather a consequence of the stretching of space itself. Einstein's theory of general relativity, with its revolutionary concept of space-time, provides the framework for understanding this cosmic expansion. It tells us that space and time are not static, but rather dynamic and intertwined, capable of stretching, curving, and warping under the influence of gravity. So, the next time you gaze up at the night sky, remember this. The universe is not just vast and mysterious, it's also stranger and more wonderful than we could have ever imagined. And amidst this cosmic dance of expanding space and time, the speed of light, a cornerstone of our understanding of the universe, remains unbroken.